Okay, so now we're moving on to part 2. So in part 2, we're going to measure 3 different reactions. We're going to measure the reactants individually by themselves, and then we're going to mix them together and see what happens after the reaction. So the first one we're doing is this 0.1 molarity HCl. And our 0.1 molarity NaOH, sodium hydroxide. And so this is the first part. And so individually, you can see when we put them on, we have our conductivities being measured. I'm going to go ahead and take those off, unplug, wash just like usual. And so this is the first line, that first measurement, where we measured the 2 beakers separately, and then we're going to measure them as a mixture together. Now they say it's measuring them in parallel because we actually have 2 sets of those conductivity measurements, and so when we're running the loop through, we have 2 separate loops that are in next to each other, and so that's what it means to be run in parallel. In series, it means that one end of this has to go through the other end of that, right? It's more of a engineering term or a physics term, and you get into that when you guys talk about electronic systems. I've mixed them together now. I'm trying to get a good mix in there. I'm going to try to split them up, roughly about half the volume in each. All plugged back in. Now we can go ahead and measure them separately. Or now we're measuring the mixture as well. There we go. So we have both of them in there, both of them submerged. Similar to what we had last time, maybe a little bit less now when I'm not quite as tight in there. Right? If we push them up a little bit too high, then we're running in, but this is about similar volume to how much we measured last time. Okay. So a little bit of a change there. And so that's our 0.01 molarity NaOH and our 0.01 molarity HCl. Gotta clean those off. A little bit of a change, not a huge change though. I'm gonna wipe up this water that spilled out of the beaker there. Plug this back in, and so now we're going to move on to the second set. This is a similar amount of materials as well, about 6 milliliters. So this is 0.1 molarity acetic acid, CH3COOH, and 0.1 molarity NH3. We can put those onto here, and you see our current not nearly as high as what they were. So about 4 milliamps total. Take those off. Rinse. Rinse. I'll unplug that before I wipe it off. I'm going ahead and I'm going to mix these 2 together. So our acetic acid is being mixed with our ammonia, NH3. Pouring in about half into each. We'll put them back on and we'll measure this mixture in parallel. So a much bigger difference than last time. So what do you think that means? What do you think has changed in this reaction? As when we measured the 2 reactants by themselves, they were much lower. Than when we put them together. So when they're in parallel, and you kind of think about the currents, it's kind of like they're additive. So the amount of current that the reactant can support by itself is added to the amount of current that the other reactant can support by itself. So that's like that 0.1 molarity NaOH plus the 0.1 molarity of the HCl. When we mix them together, then we're seeing what that new mixture is. And since we've have the same solution on each, then basically half is coming from one beaker, half is coming from the other. So they're about the same. And so you can kind of think of them as being our first set of experiments when we're doing them like this in their pure solutions. We're measuring this one separately, we're measuring this one separately, and then this value that we get is them being added together. Once we mix them, then we're measuring just that solution. So this is going to be our third experiment. So this is the sulfuric acid and the barium hydroxide. You can see we got a lot going on there. And then this one's going to be a little bit different in what we need to do. We want to get it to a specific point. And so what we want to do is we're going to add in this thymol blue, which is an indicator. And we're going to use that to kind of tell me how much of that barium hydroxide we should add in, because this one's more exact. We have to have exactly the same amount of barium hydroxide as we have in our sulfuric acid. So I'm adding in this indicator to the sulfuric acid. And so you can see that our sulfuric acid is pink right now. I'm going to put down a piece of paper underneath so we can see that, pink. We're going to add in this barium hydroxide a little bit at a time until it goes through this pink change to yellow and then to blue. All right? Once we get to the blue, then we know we're going to be able to stop. So this is our barium hydroxide. Now, as we add it in, it makes this precipitate down at the bottom. It's white, but you see our color is still pink up on top. So I'm going to keep adding it in. Still pink. All right. Now this is the beginning part of something we call a titration. A titration is where you take one unknown amount, which in this case is our sulfuric acid, and then we try to add in a specific amount of our known, in this case our barium hydroxide, until we get to a point where they're equal, which is what's going to happen when the color changes to that blue. We're still in that pink zone, but it is getting lighter. Still looking pink there. Now when I'm dropping this in, I can tell I'm getting closer because when the drops go in, I can see a very faint blue for a second there. If you look on our color, we're no longer in that pink phase. And so we're trying to move on past that to that blue. So we're kind of in that yellow phase right now. We need a little bit more barium hydroxide. There we go. Just turned it blue with that last drop there. Now we have them. We can mix them up. And we can go ahead and take this measurement. By recording its mixture. There. So you can see how that has changed. There you go, and that's the end of our 3 experiments.